In this video, we're going to take a look at binding geometry. Binding geometry is the process of attaching our joints to our model. We can then control the amount of influence each joint has over the geometry. We'll typically use a weighted value from 0 to 1 in order to control that influence. A joint with 0 weight has no influence. A joint with a value of 1 has 100% influence over the particular component or vertex that it's been assigned to. We'll use these values from 0 to 1 to balance the weighting between multiple joints. Let's go ahead and assign our skeleton to our crow character. To attach it, I'll select the root, which will grab the entire skeleton. Then I'll hold Shift and select my geometry. We'll choose Skin, Bind Skin, and we'll start with Interactive Skin Bind. I'll choose this. And with the Interactive Skin Bind, we get a separate volume around each one of our joints that controls the influence area. So let's take a closer look. I'm going to click off, and then I'll select our crow's leg. And let's zoom up here. Now we can see we get a capsule that surrounds our joint. Right now, this capsule is on that thigh joint. We can control the size of that capsule by middle-clicking on any one of these colored lines. Now, each color indicates the axis that it will control. So I'll click on the Y, the green color, and I can shift that up or down to expand or compress that area of influence. Since it's on the thigh, we'll just kind of move that up so that it's just barely touching the knee there. And let's lower the top down. Then we can click on the blue portion of our volume control, and I'll middle click, and I can squeeze that in. And as I go, you can see the surrounding color update on my surface. So whatever is encompassed by that volume will then receive some weighting. And let's continue. We'll move around here and we'll compress this in. And we just kind of want to mimic or wrap the shape of this volume manipulator around the geometry. And we want to wrap it around the geometry that's associated with the specific joint. Now we can also grab the X channel there and taper that volume in, and we'll bring that in just a little bit there, and we can taper the top in as well. And now that keeps it nice and tight just to that left thigh bone. Let's click off, and then I'll select that bone, and we'll just go to rotate. And now I can rotate, and I'll see the influence that joint has on my geometry. Now we could go around the entire model, and every time we select a joint, we can then use that interactive tool to alter that volumetric area. So now I select rotate, and I don't see my volume manipulator, but we do have it over here in our recent command. So we can just click on that to gain access back to it. And we'll start here with the X. You can see that we can just change and taper that volume manipulator in. Now that would be too small. We want that volume to extend all the way to the back of the wing. So perhaps we could grab the blue line and just pull that out. And we could, instead of influencing the shape of that volume, translate it. So I can just kind of pull that down and shift this as well in any direction. We could also choose to rotate it. We got to look a little close there, but we do have a rotate manipulator inside of here. And we've got that green line there and a blue line coming this way. So we'll just click right there, and that'll go to my rotate tool. And if we angle that with our wing, we then spread that influence to the geometry. And I'll go to my rotate tool now, and we can rotate that and see how that has updated. And I'll select the other side. Let's just undo that rotation. I'll select the other side as well and rotate that. We can sort of see, it's kind of subtle. We can see just a little bit of the differences that's happening there. On the interactive skin bind, when we create the interactive skin bind, we can change the volume type. By default, it's set to capsule, but we can also use cylinders. Now, the rest of the settings that are inside of here are consistent for other types of binding methods. So I'm going to close this up and I'm going to undo and take this back to a point before we weighted it. And I'm going to switch to our channel box so I can see any kind of history. Okay, so now we're nice and clean. And once again, I'm going to select my root skeleton, hold Shift, and select my geometry. And I'll go to Skin, Bind Skin, and instead of the interactive skin bind, I'll choose the regular skin bind. And this one here is a smooth bind. The smooth bind is very similar to our interactive skin bind as far as the end results are concerned. It's going to give it, as the name implies, a smooth appearance when we move our joints. Now, mathematically, what it's doing here is blending between joints, and that's that sharing of the weighting, that 0 to 1 weighting. We can share that across multiple joints and multiple vertices. The one we have below at the very bottom is a rigid bind. Rigid binds do not allow us to share that weighting. We get one joint per vertex. So that wouldn't work out too well for our crow, so we're going to go up to the smooth bind, and let's open those options. Our first option there is to bind to the joint hierarchy. This is exactly what we did with our interactive skin bind. We selected the entire skeleton by its root and then applied the geometry to it. We could also use selected joints. So we don't necessarily have to use all of the joints in our skeleton to influence our model. We can actually be picky and choosy. This would allow us to take those joints and use them as more of a control handle for our skeleton, as opposed to having them deform the skeleton. Next, we have the bind method. For our bind method, we can choose closest distance, closest in hierarchy, or a heat map. The closest distance is going to find the joint closest to the vertex, and it will use that for the weight distribution. If we choose closest in hierarchy, then it'll actually follow the chain in order to determine what vertices get bound to which joints. Now, this can be useful if we have joints that are very close in proximity, especially for things like limbs. What this will do if we use the closest in hierarchy, if we have the leg and perhaps maybe his wing was folded down to the side, they would be very close in distance, but the hierarchy would be very separate, as it would have to traverse up the body in order to get back to the wing. So if we chose closest in hierarchy, we would avoid any of those weights being distributed across the wing to the leg. Below that, we have heat map. Now, the heat map is nice because we get a separate heat map fall off. And this allows us to alter the spread of those weights. And so we can kind of keep these a little tighter and get some pretty accurate weighting using this method. So we're going to stick with that one. And the heat map, as we'll see as we get a little further into this, the heat map is actually going to use a color coding of sorts, where closest to the joint we would consider hot. And then the further we get from the joint is considered cold. So therefore we get a distribution based upon that heat fall off. Next down is dual quaternion. And we're going to look at the difference of these after we weight these up, but we have two real options here. We have classic linear and dual quaternion. We can also blend between the both of those. I'm going to stick with dual quaternion for now, and then we'll go to normalize weights. Normalizing weights is referring to the values that we're placing on there. With our weights normalized, all of the weights will range from 0 to 1. If we choose post, then we're allowed to force those weights to 0 to 1 after we do our weighting. So prior to doing the weighting, the weights can actually exceed a value of 1. This is actually a little bit safer, so we're going to stick with this, and it gives us a bit more flexibility with our skin bind. Going on down, we have maximum influences set to 5. That's just going to be 5 joints per vertex. So we can influence a single vertex with 5 joints. And we can choose to maintain that. Therefore, we'll never have a vertex that has more than 5 influences on it. And then we have a drop-off rate for the joint distribution as well. We're using this heat map fall off, which we're going to rely on a bit more. And we have that set to 0.5. Let's go ahead and bind this up and see what type of effects we can get. And I'm going to select our joints here. And let's see how the wing is looking. Just kind of fold that in. That's a pretty good weight distribution. It's not a very complex model, so we don't have too much to worry about with most of our skin binding operations. So any of our features there within the smooth bind is going to get us pretty good. Now, once we add a smooth bind, we're not committed to those settings that we chose. Let's just undo that. I can still go into the attribute editor and choose the skin cluster node. And I can also see this in the channel box. We scroll down, there's my skin cluster node right there. But I'll go into my attribute editor, and here I can make those same types of changes. There's my maximum influences. We have it set to 5. We can keep them. We can turn all of these things off. And also there's that normalize weights set to post. And again, I can switch to a different method there. Now, I do want to take a look here at the skinning method. This is that dual quaternion. If with all of my joints selected, when I go and twist my character's arm or wing, the geometry twists, and it actually looks fairly accurate as we're twisting each and every one of those joints. If I switch, though, and go to classic linear, you'll see that the actual volume of my geometry collapses in a bit. And we'll switch again. We'll go back to dual quaternion. And that really expands back out in this one direction there. So just going back and forth between the two, you can see what the effects are. Dual quaternion does its best to retain the volume of the surface, whereas the classic linear, which is now a dated operation, we don't use it so much anymore, does not maintain the volume. And we don't use it just for that particular reason, is that it doesn't retain volume. So by using dual quaternion, we can keep that volume, therefore we're not getting distortion from our weighting in our final character. And we'll just put that back to normal. So there we've bound our character up. It's definitely not done. We'd still want to go back and fine-tune a lot of our individual weights that we have inside there.